Welcome back, grade 12s. Now let us continue with question 4 on our review of the 2023 Mathematics Paper 1 question paper. Okay. So here we're given an exponential function. Sketch below is a graph of f of x, which has 2 to the power x minus 4. And here we're given a domain for which the function is defined. How do we know that's the domain? Because we're given that x is an element of, and we're given the set here. It starts from -2, where -2 is included, and it ends at +4, but +4 is excluded like that. So this means that you can see here the dot is shaded. If you cannot see, let me just touch it like that. Let me use a different color. Yes. Okay. So we can see that it's shaded right here and it's not shaded here, right? So it means that -2 is part of the domain, but +4 is not. Right? And we're also told that A and B are the x and the y intercepts of the function, right? Okay. So now for question 1, they're saying write down the equation of the asymptote of f. So now we're also given these keywords here, write down, meaning that whatever information we're looking for, probably we can extract it from the function itself, isn't it? Or from the given information. So we know that 2 to the power x minus 4, this -4 right here represents the equation of the asymptote. Okay. So that's what we're going to write it as. So 4.1, we have y is equals to -4 like that, because it's a horizontal line that passes through a y value like that. Okay. So now let's go on to 4.2. Now they say determine the coordinates of B. Well, remember that B here represents the x-intercept of the function. So we have y is equals to 2 to the power x minus 4 like that. So here we are solving for the value of x. First of all, we have to solve for the x-intercept. Then we are going to report our final answer as a coordinate, because they said determine the coordinates of B. Okay, so we have 0, 2 to the power x minus 4. Then if we take these two, if we take the 4 to the other side, it becomes 4 is equals to 2 to the power x. So we know that we can write this as an exponential number. So this will give us 2 to the power 2 is equals to 2 to the power x. So now, since we have the same base on either side, right, then it means that the exponents are equal. Please do not cancel out the bases like that. That is not mathematics, okay? That would be a violation. It's just that now we are using the power of the equal sign that suggests to us that whatever's on the left must be whatever we have on the right. So if we have base 2 on either side, it means that the exponents must also be the same, because here the equal sign says that these two are equal. So therefore, we have x is equals to 2. So here we're not solving for x, we are looking for the coordinates of B, but this was part of the answer. So now we can report that information. So the coordinates of B can be given as 2 and 0 like that. X value, y value. Excellent. Now let's go on to 4.3 like that. So now they're saying determine the equation of k, which is a straight line passing through point A and B, in the form of kx is given as that, right? So now let us look at this guy up here. Well, we see that A here is a y-intercept, right? And we're going to have a straight line. Let me sketch a straight line quickly here. We're going to have a straight line, right? That's going to pass through these points here. Let me just position this guy nicely like that. Yes. Okay. So now what I want you guys to know is that this value here will be the value of C, right? This will also be the value of C here. Because we know that any straight line function is given by the formula y is equals to mx plus c, like that. So if we solve for the coordinate of A, then we would have found our value of C. Okay, let's do that quickly. So we know that for C, we can say C is equals to 2 to the power of 0 minus 4, like that. Okay, so now I am using the exponential function because at that point there, the x value is 0. And I know that this C represents the y value at that point. Okay, so now C is going to give us how much? This is going to be 1 minus 4, giving us -3. So we have solved for C. Now, the next thing that we have to do here is solve for M. So I want to tell you that the coordinates of A here, we found them, which are 0 and -3. So it's easy, right? And we also know that the coordinates of B are 2 and 0, like that. So now we can quickly find the gradient so that we can quickly report, or we can report the final value here. So y1, x2 minus x1. And this is the same as, let me just go on to the next page right there. Let me just go on to the next page. This will be, then you can pick any value for your y2 here. So I'll just pick this guy of -3 minus 0. And I'll pick 0 minus 2, like that. And we have positive 3 over 2. So therefore, now we can say k of x is equals to, what's the gradient? 3x over 2, x here. And what was our value of C? We solved for the value of C and we got a -3, like that there. So this is -3, like that. And that's your equation right there. Okay, so let's just go up and check. So now for 4.4, they say calculate the vertical distance between K, the equation that we just found right now, and f of x for x equal to 1, right? So now when they're saying the vertical distance, they're saying that these 2 points where the graphs are directly above one another, well, because we're given that at x equals to 1, right? So those 2 different points, they would be above one another, like that. Okay. So how are we going to go about that? Well, easy. We can say that the distance is equals to the absolute value of f of x minus, not g of x, sorry. Not g of x, it should be of k. It should be of k of x. Well, and we know that we're going to evaluate these 2 functions at x equal to 1 there, right? So now why am I saying absolute value? Now remember that distance is neither, well, we can say that distance is a positive number, right? So now if someone starts with k minus f of x, they might get a negative value. Or if we start with f of x minus k of x, we might get a negative value. So when you have the absolute values here, they're saying, well, we do not really care about the sign. We do not really care about the sign that we're going to receive here, but rather we care about the magnitude, right? Because distance is always a positive value, like that. Okay, so let's evaluate this guy here. So for f of x at 1 minus k at 1, like that. Now the question is, what is f of x? Remember that f of x is 2 to the power, then For x, we're going to have 1 minus 4 minus into, we have k, which is 3 over 2 into 1 there, minus 3, close, and close like that. Okay? And when you punch this information into your calculator, you are going to receive 1 over 2. So the distance is 1 over 2 units, like that. Okay. So now you'll see that on your calculator, it's written ABS, right? So that just tells you that you're dealing with the absolute value. And it should display these two bars on your screen. And you can plug in some information here. This will always produce a 0 or a positive number. It does not matter whether you plug in a positive number or you plug in a negative number. It will always produce a what? That value as a positive. If you plug in a 0, definitely it's going to produce a 0 like that. Okay. So that's just additional information that you might not need to know, but you can always use going forward. Right. Now we're also given 4.5 here. They say write down the equation of g if it is given that g of x is equals to f of x plus 4. So this is a shift, my good people. And what type of shift is it? Since it happens outside of f of x, this is going to be a vertical shift. Okay? So it means that we are moving the graph either up or down. So now since they said write down, it means that we don't have to do a whole lot of calculations with this question, but we're just going to write it down explicitly so that you guys see how we could do it. So we have g of x, which is going to be formed if we take f of x and we add 4 units to it. So now the question is, what is that f of x of ours? Remember that it is 2 to the power x minus 4. Then we are going to add that 4. So we're going to get 2 to the power x like that. So this function has moved up 4 units, okay? And now it means that the x-axis is the asymptote, of this function. Now, remember that f of x was subjected to some restrictions, right? Remember that f of x, right, had its domain, okay, the domain of f was what here? It started from -2 and ended +4, but 4 was not included. So this means that g of x is going to observe the same restrictions. G of x, must observe the same restrictions, because we know that f of x only exists in this given domain here. So it means that g of x will also exist there. Okay, so we're going to keep that in mind. Let us go on. So what do we have for 4.6? Well, for 4.6, they say write down the domain of G. Write down the domain of G inverse. Rather, I should read it like that because we have that power -1 right there, even though we don't say power -1. We read this as the inverse of G of x, right? And we know that we obtain the inverse by reflecting G of x upon the line y is equals to x. Okay, so now here they're saying that we must give the domain. Well, what I want to tell you is that the domain of G, right, is going to be the range of the inverse, and the range of G is going to be the domain of the inverse. I hope I said that clearly. The range of G is going to be the domain of the inverse, and the domain of G is going to be the range of the inverse. So they are going to swap, okay? They are going to swap like that. So we have 4.6 here. So if we were to calculate now, if we were to calculate what the range, let's find the range of G. Let's find the range of G, because we know that the range of G is going to be the domain of G inverse, of the inverse, right? So now we know that this function exists between -2 and 4. So when I plug in here, I'm going to plug in -2. I get what? 1/4. So that is the smallest y value, right? And when I plug in a 4 here, I get a 16. So that is the highest y value of G. Okay. So now, since this is the smallest y value, and that's the highest y value, we would write the range as y is an element. I'm going to include the 1/4, because at -2, the function is defined, right? The function exists. And now when it comes to the other side, the upper bound here, we're going to have 16. And I'm not going to include 16 because 4 was not included. Okay. So now, since this is the range of G, well, now we know that, therefore, the domain of the inverse is simply going to be X is an element, and we just write it as it is, like that. Because we know that the domain of the inverse must have been the range of the other function, the function that we began with. Okay. So that was 4.6. And now let us look at the final one right there. 4.7 says, write down the equation of the inverse in the form y is equal to. Okay. So now for us to obtain the inverse, we have to observe a certain number of rules, isn't it? So we know that y is equal to 2 to the power x. And this, my good people, is our original function g of x. And now when we want to obtain the inverse, well, we know that the operation is to swap the values of x and y and then solve for y. So let's do the swapping. So we're going to have x here and 2 to the power y. Now, when you want to solve for an exponent there, or the variable is the exponent, then you know that you're going to utilize logs. So I'm going to have y is equals to log of base 2, taking the argument of x, like that. And this, my good people, is our inverse, like that. Okay, thank you. And I will see you on the next review. Cheers.